Folks, this time we're going to talk about the beginning of everything, the beginning of the universe. How did it all start? By the mid-1900s, astronomers knew the universe was expanding. But what caused that expansion? How did the expansion begin? Was that the beginning of time? Had the universe always been? These are some of the largest, biggest questions that mankind has ever attempted to answer. And that's one of the reasons I personally love astronomy, is because it looks at those big questions. Well, in the 1940s, something proposed was called the steady state theory. And if you say steady state, that kind of means that things are going to stay the same. It had been hypothesized that the universe always existed and never would end. And I don't know about you, but on a psychological level, I find that really pleasing. And a lot of people thought this pleasing. It was sort of Zen, the simplicity, the beauty, the symmetry of the universe, never having a beginning and never having an ending. And it was also rather hopeful for us mere mortals. Now, the steady state theory followed something which is called the perfect cosmologic principle. And the perfect cosmologic principle said that since the universe was expanding, matter would have to continuously be created in order to keep the density of the universe steady. Because the idea was, as the way it looks now is the way it has always looked. Well, steady state theory, if the universe was expanding and there was scientific data to prove that, that means at one point in time it had a certain density, and as it expanded and got bigger and bigger and bigger, how do you keep the density the same throughout the entire expansion of the universe? The only way that would occur is if matter would continuously be created. Well, we knew about Einstein. We knew E equals mc squared, and we knew matter could be created out of energy. But there's also a big rule in science, that is the law of conservation of energy. The amount of energy you begin with is the amount of energy you end with. So the only way this could be true is if there was somehow, from some source, a continuous influx of energy. And it felt uncomfortable, according to the rules of physics. Big Bang theory said that as the universe expands, it gets a little bit more diluted. So at the beginning of the Big Bang, everything was very, very dense. Matter was very close together. And as the universe expanded, it's sort of like a balloon getting bigger and bigger and bigger with that expansion. And the particles inside would actually get further apart as opposed to being very close together. The other thing that existed back in the 1940s was that because we had never seen anything older than 14 billion years, astronomers were pretty certain the universe was no more than 14 billion years old. This was the maximum age of the universe. And that was 50, 60 years ago that we knew that. So there was Big Bang theory and there was steady state theory. How are we going to determine which one was the winner, or which one actually was the true explanation of what we saw? Well, Big Bang theory suggested that there should be something called cosmic microwave background radiation. And the cosmic microwave background radiation was sort of an echo of the Big Bang. Multiple teams were looking for it, and if it was found, it would be proof that the Big Bang theory was correct. And the steady state theory, if this microwave background radiation existed, the steady state theory had no explanation for it, and this would definitely say this one was dead and the Big Bang theory was the winner. Now, what is cosmic microwave background radiation? I grabbed a picture of an explosion, and as we talk about Big Bang in this chapter, I want you to understand that it is not like an explosion. We constantly picture it like an explosion because it's something our feeble little human brains can understand. It is more an expansion than an explosion. The universe started very, very small, and as I mentioned in the last slide, like a balloon, that balloon kept getting bigger and bigger and bigger. So it's Yeah, it's not an explosion into existing space. It is an expansion of space. Again, this is hard for our little human brains to comprehend. So if you kind of give me funny looks, you're allowed, because this is kind of complicated. The cosmic microwave background radiation was actually discovered by two gentlemen in the 1960s, Arno Penzias and Robert Wilson. This is a picture of Penzias and Wilson, and they eventually won the Nobel Prize for this discovery. They were two astronomers working for Bell Labs in New Jersey, and they were working with this antenna. Now, this weird horn-shaped device is a radio telescope. It is a radio antenna. And what they were looking for, they wanted to look for radio emissions from the star Cassiopeia Alpha, the brightest star in the constellation Cassiopeia. And they were looking at brightness because with brightness and luminosity, we can determine distances and things like that about the life cycle of the stars. That's what they were actually looking at. But they were using a radio telescope. And here's the weird and crazy thing that Penzias and Wilson found. Here's the fellows, and here they have this weird horn-shaped telescope. No matter which direction they looked in the sky, they always found a weird background hiss in the radio frequencies. For example, if this was the signal they got from Cassiopeia, they got a nice radio signal from it. In the background, there was also an extra little radio hiss, not very loud, not very strong, but they couldn't get rid of it. And these two guys thought this was a problem with the telescope. Usually, often in science, if you've got a weird little background thing you can't get rid of, it's your instruments, it's your instrumentation. And because this is a big open barn, this crazy telescope, pigeons were making little nests in there. They were flying in and leaving little pigeon poop all over the place. It was terrible. It was messy in there. So the guys went in there and they swept, they cleaned the bat droppings out, they cleaned the pigeon poop out. They tried to keep this really clean. They checked all the wires. And no matter where they pointed this telescope, at any point in the sky, and no matter what season of the year, no matter where the Earth was in relationship to the sun, this crazy microwave background hiss would not go away. Well, there were other teams that were looking for this, and they, honest to goodness, got scooped by Penzias and Wilson because of the fact that they were seeing this and recognized it for what it was, while other teams were actively looking for it. And this is why these two gentlemen won the 1978 Nobel Prize for the discovery of the cosmic microwave background radiation. So what does this prove? Because this radio signal is everywhere, in any direction of the sky that you'd actually look, it proves the two pillars of the cosmologic principle. The universe is homogeneous, meaning the density is the same everywhere you look, and it's isotropic, meaning there is no preferred axis. There is not a point from which everything is very dense and then the density decreases. Everything kind of looks the same in all directions. By discovering this cosmic microwave background radiation, they proved this, and that was a huge piece in proving Big Bang Theory. So this was evidence for the Big Bang Theory, and by this discovery, it took away the steady state theory, because steady state theory had no way to explain this background hiss. So when we talk about this microwave background radiation, it is only about 3 degree Kelvin of heat that is emitting some energy everywhere, absolutely everywhere. And we'll talk about where did that come from and how did it get in all of those places as all of this unfolds. In the old days, when we had televisions that were hooked up to antennas on top of roofs, if you had an old-fashioned TV antenna, you could turn your television screen to a blank screen, And about 1% of the snow that you would see on that blank screen was actually this cosmic microwave background radiation. It was left over from the Big Bang. And because nowadays we have digital TV and people don't have those external antennas like we used to, it's kind of a sadness to me, because you could have actually seen the remnants of the Big Bang at your home on your own television set 20 years ago, but you can't do that anymore. So that's going to end this discussion about these two competing theories. We're going to come back next time and talk about where does this microwave background radiation come from.